The long-awaited James Webb Space Telescope has just made an astounding finding at the outer edges of our observable universe. James Webb Telescope just detected 7 massive structures at the edge of observable universe. These awe-inspiring celestial objects have the potential to reveal fundamental mysteries about our universe's beginnings and evolution. Continue watching to get amazed by the wonders and shocking discoveries of the Webb Telescope. When scientists first discovered primordial galaxies at the universe's edge, they felt it was just impossible. The first plausible explanation proposed was that nearby galaxies might masquerade as faraway galaxies. So they investigated these galaxies and sent the data to experts all around the world, and the result was exactly what they had hoped for despite hope. Yes, the galaxies are real, with no anomalies, and it's all thanks to NASA's superstar telescope, the James Webb Space Telescope. It not only provides us with a new perspective on the cosmos, but it also focuses our attention on the most ancient galaxies ever discovered. Astronomers believe that light from these galaxies has been traveling to Earth for more than 13.4 billion years. The results show that these galaxies existed in the universe when it was less than 350 million years old, and show the rapid emergence of the first generations of galaxies, seeing the spectrum revealed as we hoped, confirming these galaxies as being at the true edge of our view some distance away than Hubble could see. It's a huge accomplishment for the expedition, but why is this discovery of 7 massive structures at the edge of observable universe by James Webb Telescope so important to verify that these galaxies existed in the early universe? The James Webb Space Telescope is an infrared observatory that orbits the Sun approximately 1 million miles from Earth in order to uncover the first galaxies that formed in the early universe and to study stars developing planetary systems. Webb will look into every stage of the history of our universe, from the first dazzling glows after the Big Bang through the creation of solar systems capable of supporting life on planets like Earth, as well as the evolution of our own solar system. It will build on the Hubble Space Telescope's discoveries. The JWST, which is now fully operational, has 7 times the light-gathering capacity of Hubble, but will be able to see much further into the infrared region of the spectrum, revealing galaxies that existed even earlier than Hubble, thanks to its longer wavelength capabilities and significantly lower operating temperatures. Galaxy populations should be abundantly discovered before the epoch of reionization, and Hubble's previous cosmic distance record has already been broken. First of all, the finding validates Webb's capability to carry out one of its most crucial tasks, researching the early universe using light, whose wavelength has been stretched by the universe's expansion due to its extremely lengthy travel time. Redshift describes how the universe's expansion causes light to stretch, moving it farther towards the red end of the electromagnetic spectrum as it travels. This implies that redshift can be used as a distance indicator, and that early galaxies should have light exhibiting extremely high redshifts, with light stretching all the way into the infrared range, a specialty of the JWST. This discovery has upset our cosmology's fundamental assumptions. In addition, the discovery that 4 out of the 6 galaxies have extreme redshifts was made after researchers examined data from Webb's near-infrared camera and near-infrared spectrograph instrument. This suggests that we should build a more powerful telescope to confirm whether the Big Bang occurred when we believe it did. They arrived at this conclusion because these galaxies' spectra lacked the telltale signature of heavy atoms like carbon, which indicates that the JWST is viewing them as they were when the universe was only 300 to 500 million years old. The stars in the galaxies found by the Webb scans were incredibly old and massive, though. The unexpected results cast doubt on conventional wisdom on the universe's early formation and evolution, as well as earlier data acquired by Webb's less potent predecessor, the Hubble Space Telescope. Leja argues that astronomers need to be certain the strange red dots they are seeing aren't anything else before rewriting cosmology theories to explain how these galaxies came together so soon after the Big Bang. Leja claims that the majority of the alternate answers necessitate brand new ideas. Webb's near-infrared camera captured the images of these fascinating galaxies as part of the Cosmic Evolution Early Release Science Initiative. Establishing galaxies is a difficult task. The issue is that currently the universe is 13.8 billion years old and approximately 400 to 500 million years after the Big Bang. According to modern cosmology, the period of reionization began, which was the time when gas and dust began to gather to create stars and proto-galaxies. There shouldn't be such well-formed galaxies only 500 million years after the Big Bang. as observed by Webb, since this process is thought to have taken a few million years before the cosmos came to be as we see it today. The Big Bang theory is the most widely accepted theory in science regarding the universe's beginnings. It makes the case that the cosmos was once a singularity, an incredibly hot, dense, and extremely small point. Around 13.8 billion years ago, this singularity started to rapidly expand, and the universe has been expanding ever since. The amount of light components in the universe, the study of cosmic microwave background radiation, and the large-scale structure of the universe all provide evidence for the Big Bang theory. The universe's abundance of light elements like lithium, hydrogen, and helium is also consistent with the Big Bang theory's predictions. The observed abundances support the notion that these elements should have originated in the early cosmos. What exactly is going on then? Scientists are scrambling to include these galaxies into the cosmological inflation model that is already in place. But there are some flaws in the Big Bang hypothesis, no matter how ambitious it is. The Big Bang defies the fundamental law of thermodynamics, which stipulates that energy can only be transformed from one form to another and cannot be generated or destroyed. The cause of the Big Bang is unknown. Secondly, during the era of reionization, our cosmos abruptly emerged from the Dark Ages, and now we are discovering galaxies that are nearly as old as the Big Bang itself in cosmic terms. The James Webb Space Telescope is causing the Apple Card to malfunction, therefore that is the issue. All of a sudden, it occurs to us that we might need to completely revise all of the textbooks on the origin of the universe. The new research builds on earlier findings that galaxies from the very beginning of the universe were as developed as our own Milky Way. A new paper has appeared to confirm those findings by testing the galaxies to learn more about how they formed. The James Webb Telescope has discovered 6 galaxies that exist 500 million years after the Big Bang and are up to 10 times bigger than the Milky Way galaxy. If scientists have not made a mistake, it suggests that we may be missing some fundamental information about the universe. Currently, it takes many billions of years to create a galaxy like the Milky Way galaxy with 100 billion stars, many billions of years old. They shouldn't be young, larger than the Milky Way primordial galaxies that are barely 500 million years old. The cosmic microwave background radiation, which is assumed to be the leftover radiation from the Big Bang, and other evidence that contradicts the Big Bang theory point to a problem with the cosmos. The pattern of this radiation is consistent with the Big Bang theory's predictions, and there is also evidence that the universe is expanding and that distant galaxies are really accelerating in their motion away from us, the further away they are from us. The Big Bang theory's predictions are also supported by the universe's abundance of light elements like lithium and hydrogen. These streams of evidence resoundingly affirm the Big Bang theory of the origin of the universe. However, as at the time this video was created, NASA tweeted about finding a galaxy cluster of 7 galaxies with a redshift of 7.9, or just 650 million years after the Big Bang. Webb data has since changed the epoch of all that. Based on the data gathered, astronomers predicted the future growth of the infant cluster and discovered that it will probably increase in size and mass until it resembles the Coma cluster, a monster of the contemporary universe. Webb provided us the unheard-before ability to estimate the velocities of these 7 galaxies and confidently confirmed that they are linked together in a protocluster. This is a really exceptional, unique region of rapid galaxy evolution. Subscribe to our channel to stay up to date on the newest discoveries from the James Webb Telescope and other groundbreaking astronomy missions. We can observe that these far-off galaxies will eventually merge into a single, vast, mighty river by comparing them to tiny water drops in other rivers, according to a NASA scientist. In other words, our theories about the Big Bang don't really add up, do they? More Webb data will show a wealth of information that either supports or refutes the Big Bang theory. Or, who knows, maybe the Big Bang did occur, but what caused it is a very different tale. However, our adventure does not end here. There is still so much to learn, explore, and discover. The James Webb Telescope will continue to probe deeper into the universe's mysteries, revealing hidden treasures that will challenge our current knowledge and push the boundaries of human comprehension. Curious to know more? Watch the video. Another blow to Big Bang. James Webb Telescope detects a structure that should not exist. Go check it out. All right then, thank you for watching and keep exploring.